In this lecture, we're going to see how we can steal data from temporary objects using move constructors or move assignment operators. And let's try and visualize what we are going to do in this lecture. We will have temporary objects. For example, we have a temporary object here, and we either want to copy construct from this temporary object or copy assign from it. And what we want to do is to not copy the way we do with copy constructors, because in a copy constructor, we are going to do the hard work to do dynamic memory allocation. We are going to copy from the temporary object, and the temporary is going to be thrown away, and we don't want to throw that away. What we want to do instead, for example, if we are copy constructing from this temporary object, is to make our own mItems pointer point to the data that the temporary object has. Now, when the time comes for the temporary object to die, it will die, but it will die not with our data here, because we will have reset this pointer to null pointer as part of our copy construction, because that's what we're going to do here. So this is the setup we will do. We will basically be stealing pointers from temporary objects and resetting the pointers in temporary objects, effectively making the data in these pointers ours. And this is going to work really well. We're going to see this in the context of copy construction or copy assignment. And we are going to be setting up our own copy constructors or our own assignment operators, which are going to be stealing from these temporaries. And we will achieve this by using a move constructor or a move assignment operator. And all this is going to work together to make our example here work better. We don't want to be throwing away the temporary objects we create in our makebox function call. We want to reuse them and steal the data that they contain. And when the object dies, it is going to die alone. It is not going to die with the data that we need. We will steal the data we need using a move constructor or a move assignment operator. That's what we're going to do in this lecture. So the job is basically setting up a move constructor and a move assignment operator, which are going to be picked up by the compiler when it notices that we are trying to assign from a temporary object or we are trying to copy construct from a temporary object. We're going to look at our move constructor here, and the way we tell the compiler that this is a move constructor, our parameter is going to be passed as a nar value reference. And now you know that these two ampersand symbols mean that this is a nar value reference. So if the compiler sees that we are trying to copy construct from a temporary, it is going to trigger a call to this constructor here, and it will be called. So this constructor is not going to do regular copy construction. What it is going to do, it is just going to steal the pointers in our source object. You see that that's what we do here. We say that our pointer actually equals the pointer in source. So we will steal the pointer in source. We will steal the capacity in source. We will steal the size in source. That's what we do here. And the next important thing we need to do is to reset the pointers in the source object. And we do that through a special method that we will set up. And this is basically going to reset the pointer in source. And it is going to reset the size and the capacity member variables in this source object to really play it safe. This is what the move constructor is going to do. And you see that it is not doing any dynamic memory allocation. It is not doing any copies. This is going to run pretty fast, and this is what we want in our C++ programs if we happen to be using data from temporary objects. We can also set up the same thing for our copy assignment operator, and it is going to be a move assignment operator here, and the parameter is going to be a nar value reference. This is how you tell the compiler that this is going to be working on temporary objects. And again, we won't be doing any dynamic memory allocation. You see, we're not doing any copies. The only thing we do is steal the pointer in our source object, and we do that on this line here. We will steal the size, we will steal the capacity, and we will invalidate the pointers in our source object. And this is going to be all we need to get this to work, effectively stealing data from our temporary object. And this is really cool. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is move constructor and move assignment operators. We will steal the data from the last lecture because that's really all we need here. So let's grab our box container class and the main CPP file and leave out the rooster binary because we don't need that. We will generate our own, and we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us everything we need. We have the main function exactly like we had in the last lecture. We are calling our makeBox function to create a local box object that we can assign to the box array element here. And this is going to throw away the temporary, exactly what we don't want to do. Like we did in the last lecture, we are going to steal from the temporary and we are going to steal the data and avoid the work to do dynamic memory allocations we were doing in our copy constructor and our copy assignment operator. We're going to be avoiding this thing. So let's get started. And the main thing we need to do here is to set up a move constructor and move assignment operator. Let's do this. We're going to go back in our box container class. Let's go to the top, to the point where we have our copy constructor, and that happens to be here. We are going to set up a move constructor, and we can copy this little guy and put in a move constructor, which is going to be passing a nar value reference. And we say that this is a nar value reference by putting two ampersand symbols here. We can also go down and put in a copy or a move assignment operator, and we can copy what we just had and we will change it to have two ampersand symbols. So this is going to be our thing, and we will have our thing in place. Let's put in two ampersand symbols to mean that this is an R value reference, and this operator here should be triggered if we are trying to copy assign from a temporary. Let's go down and put in implementations for these things. Let's find our copy constructor. So we are going to go down here and put in the same thing we have on top here. We are going to say that we are setting up a move constructor, and we can put that down below here, and we can put in a closing curly brace. Let's do this, and we are going to pass a nar value reference here. Our move constructor is not going to do anything special. It is just going to steal the pointer from our source object, and that's what we do right here at this line. On top here on line 94, we are doing a self-assignment check. This is something you already know. We should avoid this. We are going to steal the pointer on line 97 here. We are going to steal the size and capacities. And another important thing you don't want to forget is to invalidate the pointers in the source object. And we do that by resetting the pointers and the capacities in our object. Let's go down and do that. We can use a helper private function to do this. It doesn't really need to be exported to the outside, or this guy needs to be public because we need to call this from the outside. So we're going to say void invalidate. It is not going to be a const member function because it is going to modify our things. We are going to set our mItems pointer to null PTR. Effectively resetting that, we're going to reset our size to 0, and we're going to reset our capacity to 0. This is what we want to do here. So we need to say n equals 0. And this is going to reset the data in our object, making it safe to reuse the object after we have stolen data from it. And that's what we do here. We call our invalidate member function on the source object to reset its pointers. We can also go to our copy assignment operator and make it work. I think we have it way down in this file here. We have the copy assignment operator. We can copy the code here. Let's say that this is our copy assignment operator, and we will go below it and set up a move assignment operator. And let's put in the code. This is going to be a function template as well. And we want to mark this as a nar value reference. This is what is going to trigger the compiler to call this if we are trying to copy assign from a temporary object. And we will basically do the same thing we did in our move constructor. We are going to steal the pointer and we are going to reset the data in our source object. This is what we do here. And this is going to do what we want. Let's go on top and make sure that we have a stream output statement to say that we have called our move constructor. We need to see that. Where is our move constructor? I can't find it. Let's go on top and see if we can get a hold of that. We don't have an output stream message here. We can do that. We are going to say stdc out box container move constructor called. Now that we have our move constructor and move assignment operator n, if we run the program, we will see that what we are doing here are not regular copies. This is going to call the move assignment operator, and this is going to be really cool. Okay, so let's make sure we have this as clearly as possible. And this is going to do what we want. I think we have taken out a closing brace for this loop. And now let's try to run this program and see what we get. We will pass this through our favorite compiler, which is GCC. And we have a compiler error here. What is wrong? Invalidate. The problem is that we have passed the parameters to our move constructor and move assignment operators by const or value reference, and we don't really need to use a const there because we intend to modify the source object. So what we need to do here for our move constructor is remove the const qualifier here. We don't really need this. This was in as an error from our copied code from our copy constructor and copy assignment operator, but we don't need these const qualifiers. Let's remove them. I am going to go to my move assignment operator and remove that. So where is it? Copy assignment operator, we need this const here, but for our move assignment operator, we don't need this const qualifier. You need to be aware of this, so let's make sure we don't have this in. And after we have this, let's go in our class declaration and remove these things for our move constructor. And we don't need this const here. And let's go to our move assignment operator and remove the const here. And now if we build our program, it is going to work, at least hopefully, if we don't have any more boo-boos in. The build is good as we see here, so this is a good sign that this is going to work. Let's pass this through our terminal. We're going to bring up a new terminal window. We're going to run Rooster. And we are going to see that the box container object is still destroyed, but what is going to be destroyed is not going to be destroyed with the data that we care about. We will have stolen the data in our object. If we want to really prove this, we can go in our destructor and say which object was destroyed and say the size of the object that was destroyed. We can say that. So where is our destructor? And we can say the size. So box container object with size. We can put the size out here. And hopefully this is going to prove that what we are destroying in our lines here are objects that don't really point anywhere because we have reset them using the invalidate call here when we did steal their pointers. And this is really what I want you to see. So let's pass this back through our compiler. Let's build again. The build is going to be good. So let's clear and run Rooster. You see that the objects we destroy in our loops here have a size of 0 because we have invalidated them, but when we hit the end of our program, the objects we destroy have a size of 20, and hopefully this proves that we have effectively stolen the data from our temporaries, and what we are destroying on these lines here are really shell objects that don't contain anything. The content has been stolen to be managed by the box container objects that we have in our array here. And this is really what I wanted you to see. This is all I had to share in this lecture. I hope you found it interesting. Again, the main message is that if you want to enable move semantics for your types like we have box container here, all you have to do is put in proper move constructors and proper move assignment operators that don't do the regular thing you do in copy constructors and copy assignment operators. What you want to do in move versions of those things is to steal from temporaries, and remember to reset the data in your source temporary object after you have effectively stolen from it. And that's going to be really cool. In the next lecture, I am going to show you that it is actually possible to even steal from L values. Go ahead and finish up here and meet me there.